So we're going to go a slightly different direction from linear functions, and we're going to look at a new function called an absolute value function. So we're going to start with what the graph of an absolute value function looks like, well, and what absolute value is, and eventually we'll learn how to solve equations with them. So the first big thing that we need to know is what is absolute value. An absolute value is the distance a value is from 0. Okay, so that would be, looking at, regardless of whether I am on the positive side or the negative side of 0, the distance I am from 0 is always going to be positive. If you've ever seen the movie Ferris Bueller's Day Off, when they take Cameron's dad's car and go out for the day and realize how many miles have been put on it, and Cameron's freaking out, that his dad's going to know, and Ferris is like, oh, well, just drive backwards, thinking that would just negate the distance that they traveled. But the problem is it doesn't matter what direction you're going, you're still going a positive distance. So the notation for absolute value, that's basically what he was talking about, is absolute value, is putting these bars around the x. And what that simply means is, regardless of what the x value is, when I take the absolute value of it, I get positive, unless the number is 0. So that means the absolute value of 4 is 4 because it's 4 spaces from 0, but so is the absolute value of negative 4. It's just 4 spaces on the other side of 0. So what this means is that we're essentially taking the line y equals x, which would extend down into the negatives. Okay, if I took the line y equals x, all of the negative values, so that's this part of the line right here, are going to be negated and made positive. So that's why we get this V shape. All of the negative x values become positive. And then I can take, so we call this the parent function because it's the simplest version, f of x, or that's function notation, y equals, we could write it this way as well, y equals the absolute value of x is the parent function because it's the simplest version of absolute value. We can take that graph and we can move it around, so we can shift it up and down, left to right. We can make the V open slower or make it open faster, so that means wider versus skinnier, and so on. And then we have a special point called the vertex, and that's the lowest point of the V that we have opening up here. So my vertex is this point right here, which for our parent function, the vertex is at 0, 0. Okay, so translating it and transformation just means we're changing its location. So instead of having the vertex at 0, 0, I'm moving the graph elsewhere. All right, so let's look at, first, how do I determine the vertex? How do I graph these things without having to make a chart of values? Okay, so I could make a chart of values, but we're going to remember that the generic form of any absolute value is going to look like this. Okay, so the values for each of these. So my vertex, I'm going to call it V, is going to be at h, comma, k. So what that means is if this value right here, the minus h becomes a plus h, the number for x was negative. And the a is going to affect how I find my other points. So we're going to call it, and I'm going to put it in quotations, slope. It controls how wide or skinny the V is, and also whether the V opens up or whether the V opens down. Okay, so if I look at y equals absolute value of x plus 2, okay, there is no k value, so I can say that that's plus 0. So I know my vertex is going to be at minus 2, comma 0. And I know it's negative 2 because this x minus h became x plus, so that I had to put in a negative 2. So I have two ways to graph. I can make a table of charts, or a table of values. Okay, so I know I have 1 point at negative 2, 0. Since that's my vertex, I might choose negative 3 and negative 1 to plug in, so that's 1 point on either side. So if I plug in negative 3, I have the absolute value of negative 3 plus 2. That's negative 1 inside there, and the absolute value is 1. If I plug in -1, I get absolute value of 1 is 1. So that's one way. So I'm going to go to -2, 0, and then graph my other 2 points and make my V. Now that's pretty cumbersome to have to do all this arithmetic. So what I can do to graph, instead of having to do all of that, is treat the value in front of the absolute value, which in this case, notice none of these have a value, so we're going to say that it's 1. Okay, I can plot my vertex and then use that quote-unquote slope to help me find the other points. So my vertex for this second one is 1, -3, because it's x minus h, it stayed minus, so it's 1, and then the plus k became a -3, so it's -3. So then my slope is 1 over 1. So I'm going to plot my point 1, -3, and then since I know it's a v, that's pretty hard to tell that that's 1, 3, okay. Since I know that my slope is 1, I am going, and I have a v, I'm going to go up 1 and both to the left and to the right to signify both sides of the v. So I go up 1 and both to the left and to the right to get my whole v. Okay, so the question's going to pop up. Find the vertex of the third one, and then I want you to take a second and graph it, and then it'll see if you have the same graph that I do. Okay, so I got the vertex of -2, +4. Okay, so I'm going to graph that. Let me change colors. So I'm going to go out -2 and up 1, 2, 3, 4. And then with a slope of 1, I'm going to go up 1 and to the right 1 and also to the left 1. So my graph should look like this. So all 3 of these open up, and we're going to pretend the V's are perfectly straight lines. It's hard to do with this pen on this iPad. Alright, so the A value, so that slope that we're calling, if it's positive, my V opens up. If I were to have a negative value, the V would open down. If it's a number that is positive but less than 1, it's going to make it open wider, and so on. Just like the slope of a line is the steepness. So that A value controls the steepness. So let's look at y equals 3 times the absolute value of x. There is no h and there is no k, so that means my vertex is at the origin, and my slope in this case is 3 over 1. So from 0, 0, I'm going to go up 1, 2, 3, and both to the right and to the left 1 to get my v. So this one, the slope of 3 is very steep, so that makes the v open narrow. Okay, let's do one more together and then I'll have you do the last one. Alright, so I've got my vertex again. There is no h and no k, so that means it's 0, 0. And my slope is 1 over 4. So from 0, 0, I'm going to go up 1 and to the left and to the right 4. 1, 2, 3, 4 here. And then from up 1 and to the left. 1, 2, 3, 4. So remember that negative means the slope goes down. So find your vertex and then use your slope to find the 2 other points. So question bubble is going to come up, but then the graph will show up, so make sure your graph agrees with mine. Alright, so we've been doing this already. Okay, so it says find the vertex, use the A value, treat it as a slope, and go up and both to the left and right, or down and both to the left and right. So let's look at this part A. So I have a vertex here, HK. It's stays minus 3, so it's going to be 3. K is 1. So my vertex is at 3, 1. My slope is 2 over 1, so I'm going to go up 1, 2, and to the left, and up 2, and to the right. So to the right, to the left, and I make my V. Okay. I'm going to do D, and I'm going to have you guys do B and C, and we'll compare your answers when you come into class. So the vertex for D, there is no H, so it's 0, and K is 3. So my vertex is at 0, 3. My slope is negative 3/4. Now the negative's out in front, so that means I make either the 3 or the 4 negative, not both. So if I put it on the 3, that means I'm going to go down 1, 2, 3, and to the right 1, 2, 3, 4. And I'm going to go down 3 and to the left 4, 1, 2, 3, 4. Okay, so I want you to do B and C, make the graphs for yourself. It'll ask you on here what the vertex is, but then make the graph using your slope. Okay, last but not least, I've got, these last two that look slightly different. Okay, so I've got 1/4 for absolute value 4 minus x. So in this case, if I, thinking about what the x value is for my h, you can think of it as 1/4 absolute value of negative, to just swap the order. Either way, if I plug in 4, I get 0 inside. So my vertex, my h value is still 4 because it's minus 4. And my k value is minus 3. So I've got 4, negative 3, 1, 2, 3, 4, 1, 2, 3. And then my slope is 1/4. So I'm going to go up 1, 2, 1, and to the left 4, 1, 2, 3, 4. And then I'm just going to make some extra 1, 2, up 1, and to the right 1, 2, 3, 4. And there's my graph. So the second one's the same thing. What would I have to plug in? Okay, I can treat it as 1 minus x, which is the same thing as y equals absolute value of negative of x minus 1, and then minus 2. So my vertex is hk. And then my slope is, since there's no number out in front of the absolute value, it's just 1. So I'm going to go up 1 and to the right 1, up 1 to the left 1, and I can make my graph.